Okay, so now let's see how we can do that automatically. Okay, if we don't have to do that manually. And for that, we have this algorithm, which is called Otsu. And this is something you will do for your programming assignment 5 as well. And it's a very simple algorithm. So pay close attention. If you follow, I think it's few lines of code and you will be able to implement this. Just try to understand like the basic concepts here. Okay, so the idea is, given an image, you want to perform image binarization, which means you want to separate like foreground pixels from background pixels. So that's the high level goal. And what this algorithm is going to do is it's going to automatically find that threshold for you, which you can use to actually separate those two categories. Okay? And how it does that? It will try to maximize the between class variance. Okay, we'll talk about what this between class variance is. So variance, you all know. So for example, if you have some kind of distribution, if the values of the data points in that distribution actually varies a lot, right? For example, a Gaussian, which is very thick, because the value of mean is actually varying a lot, right? So that means your variance is high. But if the values of those data points actually is not varying a lot, then it will be like a very compact, or you can say like a very thin Gaussian, right? So then your variance will be low. Now that's like within class, but what we're trying to do is we're trying to maximize between class variance, which means that in this case, since it's image binarization, you have two different classes, foreground and background. What you want to do is the values of the pixels from one of the class, let's say foreground, should be as far away as possible from the values of the pixels, which is from your background class. Okay, so whatever that distance is, whatever that variance is, you want to maximize that. Okay, so let's see like what that means mathematically. Let's say we have two different classes. We have, let's say this is foreground and one is foreground, two is background. And mu is like just mean of all the foreground pixels. Mu2 is like mean of all the background pixels. And mu is like mean of all the pixels. P1 is the probability distribution of the foreground pixels. P2 is the probability distribution of the background pixels, right? Once you have those statistics, you can compute between class variance by this simple formula. Okay, you subtract the means, take the square, multiply with the probability distribution, just add these two. So this gives you between class variance. Because what you're doing is you're actually subtracting the mean and then taking this probability distribution here, right? And if you just try to solve this equation, you will get something like this. You can open the braces here. Okay, so we don't have to do that here, but that's fine. So this is the formula which you're going to use, which is giving you between class variance. And what it's trying to do is you have probability distribution of foreground, probability distribution of background, mean of foreground, mean of background. Okay, so those are the numbers you will need, and you can just compute this formula and then you're done. You just try to maximize it. Okay, so and yeah, this is also interesting because in one image, if you're saying that P1 is the probability of your foreground pixels, then the probability of the background pixels is automatically going to be 1 minus P1, right? Because you just have two classes, and you know that the sum of probability is also is always 1. So you don't have to compute P1 and P2 separately. Just compute P1 and you will get P2. And we'll talk about how you can compute P1. All right, so now pay close attention. This is the whole algorithm which you'll have to implement. And we don't have to go through like each step. I will just explain it to you. And if you have questions later, you can ask and we can go through this again. So you saw that to compute between class variance, you need 4 numbers. You need P1, P2, mu1, mu2. Okay, so P1 is probability of your foreground pixels, probability of background pixels, mean of foreground pixels, mean of background pixels. So let's see how these 4 numbers are computed. And then basically you just use that formula and that's going to give you between class variance. And then we will talk about like what this loop is actually doing here. So P1 is probability of any pixel being a foreground. Okay. Now let's say you selected like a threshold hue, which says that all the pixels having intensity less than U are foreground and greater than U are background. Okay, so now you're computing foreground, so you will go from 0 to U because all those pixels are your foreground pixels. And what you do is you just compute, like you just count how many such pixels you actually totally have. That's it. So basically, in layman terms, if I try to explain it to you, let's say you have 1,000 pixels in total. All right. And let's say I set a threshold of 100, which says less than 100 is foreground and greater than 100 is background. Then you're just going to count how many pixels have intensity less than 100. Okay. If it's 300 pixels, your P1 is going to be 0.3 because you have 300 pixels which have intensity less than 100. And simply your P2 will be just 0.7. You just subtract by 1. Okay, so it's that trivial. You just count like number of pixels you have in foreground and number of pixels you have in background. And again, considering this threshold. And this is important because this threshold is something which you have to compute. So you don't know that threshold. Okay, which means that for different threshold, your P1 and P2 is going to change. And that's what we have to optimize here. Now, once you have P1 and P2, you can easily compute mu1 and mu2 as well. Mu1 is just like mean of all the intensities. Basically, we are just taking like the actual intensity value, and then we are just multiplying like how many such pixels we do have. And we just again sum all those and then divide by the total probability. That's going to give you the mean. Similarly, you can compute mean for the second class, which is the background class. Okay, so these are simple formulas. Now, once you know that, now comes like the tricky part, how to find this U. Okay, so again, this is a very simple, I will say brute force algorithm. If you know what brute force is something you try everything. All right, and everything in this case is you have pixel values ranging from 0 to 255. So basically in brute force, what you will do is you will compute between class variance for threshold 0, for threshold 1, threshold 2, threshold 3, all the way up to 255. So that's the brute force. And that's exactly what this Otsu algorithm is going to do. And that's what this loop is actually doing here. So inside this loop, you will compute your interclass variance for all the possible threshold values. Okay, so you start from left, you compute the interclass variance, you move to the next step, you compute it, and then as you move from 0 to 255, for whichever threshold value you found that you got like the maximum interclass variance, that's the solution. That's it. All right. Now, this is like a result of this Otsu algorithm. So no manual fine-tuning, no manual analysis. You just use that algorithm. You give this image to the algorithm, it will give you this output. So pretty cool, right? And this is a very cool visualization of like how this algorithm works. The x-axis is showing you different values of threshold, starting from 0 all the way up to 255. Okay. The black bar, which is actually moving, is showing the location when that interclass variance is being computed. And the red curve is the actual between class variance computed. Okay. So let's follow from the left. When you start from the left, the threshold is 0, which means that you have, let's say, 0 foreground pixels, and all the pixels are just background pixels. And again, if you use that formula, you will see that your between class variance is actually pretty low. Okay, because the reason is in one of the class, all the pixels have value 0. I mean, there are no pixels, right? So there is no variance. And in all the other one, like there is a lot of variance within class. So it will give you a very, very low number. And as you keep moving towards the right, you will see that your between class variance is actually increasing. And it will peak at this position when I think the threshold is something like this, and again, this is automatically computed. So I can't say like why we get this value, but we can visually inspect. This point kind of separates like these two peak very, very nicely, right? And what's trying to optimize is the between class variance is actually maximum at that particular point, and that's why that point was chosen.